6.1, we are working with functions. We'll start with just sum and difference as algebraic operations with functions. So the notation is what's weird here. The sum of functions f plus g in parentheses of x is just corresponding with f of x plus g of x. The difference is then just f minus g of x, or f of x minus g of x. So really what you want to get used to is the difference in notation. The concept is something that you are likely pretty familiar with already. When we start talking about domain of these functions, if you just look at the function after you have done the operation, it's pretty straightforward. But in the context of the domain of f and the domain of g, it will be the intersection of those domains, which basically means that if it's excluded from f, it's excluded from the combination of f and g. If it's excluded from g, it's excluded from the combination of f and g. So that's why it's the intersection. Anything that gets excluded from one must be excluded from both. And that's what I'm outlining here. So cat in the background. If I give you an example, say you have a plane with a trajectory p of x that's given by negative 3x squared plus 5x plus 120, and inside that plane somebody tosses a ball that has its own trajectory within the plane of b of x, which is negative 1/2 x squared plus 2/3 x plus 1, then the position of the ball in space overall is going to be given by the sum of those two trajectories, p plus b. So we can solve for that explicitly by taking the two functions and adding them together, p of x plus b of x, to get negative 7/2 x squared plus 17/3 x plus 121. And then, but it's also, just keep in mind, the same as taking the trajectory of the plane and then adding the trajectory of the ball to it at any given time. So what is the position when x is equal to 0? So that would be our time, effectively. P of 1 is 122 feet. B of 1 is 7/6 of a foot. So P plus B of 1 is the sum of those two values. Or you can just evaluate our function P plus B of x at 1 to get 739 divided by 6 feet, or 123.167-ish feet, for the height of the ball at some specified time inside of the plane. For you to get an idea of what's happening visually, I recommend that you graph all three of these functions. Graph p of x, b of x, and p plus b of x on your calculator, just so you can see how they compare. Like, how does the function p of x is obviously bigger than b of x, but when they're added together, it's going to make a small change to p of x, even though b of x is much smaller. That p plus b of x graph is going to be different from p of x. What is the domain for these guys? Since both of these functions are polynomials and we're adding the polynomials, nothing was excluded from either one, and so nothing is excluded from their combination. It's an important thing to keep in mind for addition and subtraction. Multiplying and dividing gets much more complicated. So a product of functions, that's your multiplication, f times g in parentheses of x, is f of x times g of x. And f over g inside parentheses of x is f of x divided by g of x. That's your quotient of functions. The domain of f times g is the same as f plus g was, but f divided by g adds something. So it's also the same, but you also have to exclude any x values where your g of x function gives you 0 because you're dividing by g of x. So let's look at an example. If I give you an f of x that is 2x squared plus 5 and a g of x that is x minus 2, then f of x times g of x is going to just be their product. So I effectively just FOIL that, getting me 2x cubed minus 4x squared plus 5x minus 10. Again, a polynomial, no problems, right? Nothing's excluded from f or g, so nothing's excluded from f times g. For f divided by g, I have 2x squared plus 5 over x minus 2. So I do have to exclude the point when x is equal to 2 from my domain because I can't divide by 0. So that's where that concept from here comes in, where if g of x is equal to 0, I have to exclude that x value from my domain. Let's just evaluate those at a value. So f times g of 4, so 2 times 4 squared, which is 16, plus 5 times 4 minus 2. So that's 37 times 2, or 74. Versus f divided by g at the same value, I would have 37 divided by 2, just as an example. So notice that that is f of 4 times g of 4, right? F of 4 is the 37, g of 4 is the 2, and that's what gets me 74, and f divided by g. F of 4 is 37, g of 4 is 2, so 37 divided by 2. You can do the same thing in a tabular format, which really just means that I build a table with my x values, my f of x values, and my g of x values. So I don't even need the function to do this. If I have the values, I can construct these function operations. So I'm giving values for x, f of x, and g of x, and then from those we'll find f plus g, f minus g, f times g, and f divided by g. So for f plus g, I just add my f of x and my g of x. So negative 1 plus negative 3 is negative 4. F of x plus g of x for 0 plus a negative 1, negative 1. 3 plus 1, 4. 8 plus 3, 11. 15 plus 5, 20. 24 plus 7, 31. Very straightforward. All you do is take the numbers in your f and g columns and then combine them in the way that's described. So f minus g, I take 1 minus a negative 3, so that's 1 plus 3, or sorry, negative 1 plus 3, which is 2. 0 minus a negative 1 gets me a positive 1. 3 minus 1 gets me 2, 8 minus 3 is 5, 15 minus 5 is 10, 24 minus 7 is 17, and so forth. F times g, same idea. Negative 1 times negative 3, 3. 0 times negative 1, 0. 3 times 1, 3. 8 times 3, 24. 15 times 5, 75. 24 times 7, 168. Just do the operation that is being described. F divided by g, negative 1 divided by negative 3, 1/3. 0 divided by negative 1, 0. 3 divided by 1, 3. 8 divided by 3, 8/3. 15 divided by 5, 3. 27 divided by 4, 27 divided by 4. Right? Okay, please let me know if you have any questions.